Hello, today we're doing an experiment to find specific heat capacity of a metal again, but this time we're doing a different procedure. We're going to use electrical energy to be provided to the metal, and we'll heat up the metal, we'll use the energy, and we will calculate specific heat capacity of the metal by electrical method. So for that, I need a device called the immersion heater, which looks like this. So this is a device that uses electrical supply. So when I connect it to the source like this, it basically heats up and it fits right into this block of aluminum here, which is going to be my metal. It fits right in, and when it heats up, it's going to heat the metal from the center. And I have a digital thermometer which fits in over here, which is going to measure the temperature for us, because I obviously cannot stir as I measure the temperature of the metal, and I need to measure the temperature from the inside as much as possible. So this is a setup to do that experiment. Now, my circuit to provide electrical energy to this immersion heater is, I have a power source here, which is set to 10 volts, and I here connect to one end of the heater, and then from this other end of the heater I have here an ammeter in series, which connects to our resistance to avoid a short circuit, which goes back to my power source. So here you have a loop, a series loop of a resistor, the source, my metal, my heater, and the ammeter all in series. And my voltmeter obviously is connected in parallel, as you can see, to my heater. So this is going to give us the voltage provided to the heater, and this is going to give us the current in the circuit. Why do I need voltage and current measurements? Well, because I am providing energy from electrical energy. So to measure electrical energy, I need the electrical power and the time. Because if I multiply power and the time, I'm going to get how much electrical energy I'm putting in to heat up the metal. And voltage times the current, as you know, is electrical power. So that will be the two measurements that I make over here, the electrical power. And when I multiply that by time, which I will measure on my graph, that will be the value for the energy. Setting that equal to mc delta t, I will measure delta t using my screen graph, which is formed by this device, and the time will be the horizontal axis. And I will measure the mass using the scale. The only unknown in that formula is going to be the specific heat capacity, which will be our calculation. So one thing I want to emphasize before I start the experiment is that it's important to know the corresponding values for the time and the change in temperature. So it doesn't matter how long we heat, it doesn't matter when we start timing, but it matters that in the formula, the delta T time and the delta T temperature change do correspond to each other. So all we need to do is to see a significant change and measure the temperature difference within that time that it occurs in. So let's start our experiment. So we're going to need the mass of the metal. Let's measure that. And we see that is 1018 grams. We will be looking at, when you connect the digital thermometer, you see our axis for temperature versus time are ready to go. So our lab technician is helping me now. She's going to start the current, and immediately you see our voltmeter reads 6.10, and our ammeter is measuring 2.13 amperes. And as you can see, we have made some insulation with some cotton around so that the heat loss is minimized. Okay, now we'll start the experiment. Yes. So you can see that all this setup is working. The initial temperature of our metal is there, and slowly we should see it heating up, but obviously this is going to take a long time. So we wait. All right, so as you can see, it's been more than a minute and you can see the temperature is going up. Okay, so you can see it's already been more than 2 minutes. So I'm gonna stop collecting and we're gonna use this graph and measure the time from the axis as well and time to calculate.